All right, this is our first video in our series in Algebra 2 and in our first unit in Algebra 2. And we're going to be looking at relations and functions, and we'll start with an introduction, some definitions, and then we will go through a few solved examples. So the first thing I want to point out are the various ways that you can represent a relation or a function. And we'll define what a relation and a function are in a moment. But first, let's just talk about the various ways they could be represented. And I'm going to first be working with a relation that's graphed down here, okay? And I'm going to be showing you how you could represent that relation using ordered pairs, mapping diagram, and a table, and it's already represented as a graph on your screen. All right, so the particular relation we're dealing with is graphed by these 3 points. And so ordered pairs are really just a list of the points. So 1, 2, 1, 4, and it looks like 4, 1. And often mathematicians write those as in set notation with those curly brackets, meaning we're looking at a set of points. A mapping diagram is another way of representing that relation, and it's often represented with your numbers in a couple ovals like this, and this left oval will represent the input, the right one represents the output. And so we have 3 inputs. We have a 1, and a 4, and we have 3 outputs, 2 and a 4 and a 1. And we can just represent using arrows which input leads to which output. Now, we have something unique going on here, that we have a repeated input, right? We have 2 1s. And so another way of representing this could be to only draw the 1 once and to show with your arrows that the 1 as an input could lead to an output of 2 and also an output of 4. A table is probably the most familiar to you here. We'll just have an XY table. X is typically our input variable, Y is typically our output variable, and we have a 1, 2, 1, 4, and 4, 1. Okay, so different ways of representing a function there, or a relation. And lastly, which I'm going to use a different relation here, a different example to show you, is an equation. Okay, and here I have a red line, and we can represent that red line with this equation. Y equals 3x plus 2. Quick reminder, we have a slope of 3, up 3 over 1, and we have a y-intercept of 2. We'll do more reminders of that down the road. Okay, so y equals 3x plus 2, and you could use just an equation to represent a function or a relation, and you don't need to show the graph along with it, but here I am showing you the graph just so you can make a connection. Some vocab terms before we get into our examples here. And these are just terms that you just need to memorize and remember. The domain is just the set of all input values. Okay, so thinking back to the example that we just did, what are all the possible values in that input oval in the mapping diagram? And then contrast that with the range, the set of all output values. Okay. Now we're going to get into a definition that's really important and ultimately getting us to a definition of a function. Okay, we will be talking about functions much more than relations in this class, but let's start with a relation. So in math, a relation means a set of pairs of input and output values. Really, all that means is anything we showed up here. Okay, so here we have some input and output, input, output, input, output, and we have a set of pairs of them, a set of ordered pairs. Same with a mapping diagram, same with a table, same with a graph. So really, a relation is just a bunch of points on a graph or a set of ordered pairs that represent an input and an output. A function, however, and this is much more important to be aware of, is a particular kind of relation. Okay, so a function is a relation in which each element of the domain corresponds to exactly one element of the range. And that's tricky to think about what that means. But each element of the domain, so each number, each value in the domain needs to match up or correspond with exactly one element of the range. So not more than one is what's most important. And as the counterexample you'll see here, back up with this mapping diagram that I'm highlighting right here, This is what makes this guy not a function, because that particular value of the domain, that 1, corresponded to multiple elements in the range, a 2 and a 4. Okay, and visually there's a great way to check if something is a function or not. So in my little graph that you're seeing right here, we can do what's called the vertical line test, and I'll show you that. If we can ever draw a vertical line on a graph that hits more than 1 point, then we're dealing with a relation that is not a function. So as an example right here, this vertical line hits 3 points. And so that means for that particular value of x that the vertical line is centered on, there are 3 members of the range that correspond to that value of the domain. So it's not a function. Okay? The independent variable, another next definition, represents the input of the function, and our independent variable is typically represented as x. In a physics class or in a social science class, you might see it often represented as t, perhaps. But it doesn't matter what letter you use or what concept in the scenario it represents the input of the function. Okay, we'll typically call it x, and the dependent variable typically is represented by y in a math class, represents the output of the function. Okay, a couple examples here. Domain and range. Okay, so I have a relation here. Remember, a relation is just a set of ordered pairs. Okay, and our domain is simply the set of the input values. So we have -2, 6, 5, and 3. And some teachers might care more about this than I. Some teachers might want you to put that domain in numerical order, increasing order. I don't think that's terribly important, but definitely make sure you're following what your teacher wants you to do. And the range is 5, 7, 3, and we have multiple 7s, right? Are you seeing that? So I'm not going to write that as a duplicate. The range is just the list of the possible output values, so we don't need to write the 7 twice. All right, so this is probably the most important practice problem we'll do in this video right here, and it looks like there are 4 of them that we'll take a look at. Is it a function? Okay, so in other words, maybe a better way of thinking about it is, can we find any that aren't functions? Can we find any where a input value leads to multiple output values? And looking at this, we'll go on the left side first and the right side. So it looks like 0 leads to 6, 5 leads to 8, 3 leads to -3, 7 leads to pi. Those arrows are crossed. That doesn't really mean anything. So yes, that is a function. Let's look at this next one. And I'm going to highlight in red what keeps this from being a function. 3 leads to a 2, and 3 also leads to a 0. Okay, so that's what keeps it from being a function. We have an input value of 3, and we don't know if we're going to get an output of 0 or an output of 2. Okay, I like to think of this as being non-predictable, unpredictable. You feed this function a 3, you don't know what you're going to get out. Okay, so this is a no, not a function. Similar idea over on the right-hand side with our ordered pairs. You really just want to look for repeated x values and see if they lead to different y values. So let's see here. We have a -2, 6, 5, and 3. Looks like it's a function. Think about this though. The fact that both of these lead to a 7 is okay. We can have repeated y values. That is an okay thing. As a quick example here, I'm going to just draw a parabola. Here, right here, and right here, we have 2 repeated y values. Okay, we have 2 occurrences, 2 different points with identical y values. That's still a function. It still passes the vertical line test. Okay, so this is a function up here. And looking at the one in the lower right here, looks like it's not a function because of these values right here. A 2 leads to a 5 right there, and a 2 leads to a 3. You feed this function a 2, you don't know what you're going to get out. It's not predictable, it's not a function. Vertical line test, we went over that a little bit earlier. I think you can see that this guy fails the vertical line test. and this one will pass the vertical line test, okay? So any particular vertical line that you have on the right-hand one will only ever cross our function once. So this is not a function. I abbreviate function fxn, and this is a function, okay? And then function notation, you'll see this a lot. You'll see f and then parentheses x. We read that as f of x, okay? F is a function of x. F is the name of our function. You don't read it as f times x. It's not a multiplication. It's a substitute for y, okay? So we can say y equals 3x plus 2. We can say f of x is 3x plus 2. It helps us when we're dealing with different scenarios. Here we have maybe revenue in your business as a function of time. Revenue is R of t, R for revenue, t for time. So this t is our independent variable, and R of t, the entirety of R of t, is our dependent variable, okay? And then also in your business, cost is a function of time as well. So C of t will be your dependent variable, and t is your independent variable. So just to be super clear, t is the input, and C of t is the output, okay? Input over here, t, right? Okay. Evaluating a function, evaluating means plug in. So here f of x is 3x plus 2. All we need to do is plug in 3 for x. So this is f of 3. So 3 times 3 plus 2. F of 0 is 3 times 0 plus 2. F of negative 5 is 3 times negative 5 plus 2. You can do that multiplication. I'll do one of them for you. This is going to be a negative 13, or you can do the arithmetic. I'll let you do the rest of the arithmetic as needed. You can also do this in a little bit in reverse. If f of x is negative 6, so that means negative 6 gets substituted in for f of x, we might need to solve for x. So our output is negative 6. What was the input that was fed into our function? We can just do the same thing to both sides, subtract 2 from both sides. Negative 8 is 3x. Divide both sides by 3. X is negative 8/3. And so that what that means is f of negative 8/3 for, again, for this equation up here we're working with, will be equal to negative 6. Okay, but our solution for x would be negative 8/3. All right, nice. That's a good place to stop right there.